In this video, we're going to be talking about algebraic expressions, and we want to answer the questions, what is an algebraic expression, and how do you write algebraic expressions? So first of all, what is an algebraic expression? An algebraic expression is a number sentence that contains a variable. That's all it really is. There's nothing too complex about algebraic expressions. They're just number sentences that contain variables. And remember, a variable is a letter or symbol used to represent an unknown or a changing value in math. So whenever we have something that we don't know the value of, or the value is always changing, we use a letter to represent that amount, and that's called a variable. So on the screen, I've got lots of examples of algebraic expressions. So you can see that they're all just number sentences that contain a letter of some kind or multiple letters of kinds. So we have x plus 2, 4 minus b, c to the second power, h divided by 12, so on and so forth. You see all of these number sentences contain a variable. So what is not an algebraic expression? We need to make sure we get this clear. Equations are not algebraic expressions. So whenever you have an equal sign or you insert an equal sign into your number sentence, it is no longer an expression. It becomes an equation. And that's not what we're talking about in this video. We're not talking about equations. We are talking about expressions. So no equal signs at all in this video. And then also, what are not algebraic expressions? Numerical expressions, number sentences that just contain numbers. All of these number sentences don't have equal signs, but they also don't have a variable. So they're just called numerical expressions. They are not algebraic expressions. So that's what an algebraic expression is. So how do you write an algebraic expression? Well, algebraic expressions are used to represent mathematical relationships in a short and simple way. It's kind of math shorthand for situations where we don't know something, but there's still some type of mathematical relationship there, and we need a way to write it or express it mathematically. So these three steps typically will allow you to write an algebraic expression for most situations. So the first and most important thing you need to do is identify what is unknown in the situation and use a variable to represent it. So you have to read a situation and decide what's unknown or what is changing in this situation that we can't really write a number for, but it does have a value. That's the most important step, because every algebraic expression will contain an unknown or changing value, and that's the first thing we need to find out. Then from there, we need to use clues from the context to determine what operations and numbers are being used in the relationship. And this can vary quite dramatically. We can use multiplication, addition, subtraction, all these operations. We just have to use clues from the situation to determine what operations and numbers are being used. And then finally, we want to write that expression using the variable, the numbers, and the operations in the appropriate order. So let's take a look at an example here of a simple situation where there's something unknown, but there's still a relationship here. The temperature increased 5 degrees. Okay, that's a mathematical statement, but we don't know what the temperature was to start with. So we want to write an expression that represents the current temperature. Even though we don't know what the original temperature was, we still can write an expression for this. So the first thing we want to do is identify what is unknown in this situation and use a variable to represent it. So we don't know what the starting temperature was before the increase, so we're going to call it T. T is the starting temperature. It really doesn't matter what letter you use as long as you define it and say T represents this. So T in this situation is going to represent the starting temperature. Well, now we're going to use clues from the context to determine what operations and numbers are being used. Well, what is happening to T? The original temperature is being increased by 5 degrees. 5 degrees are added on. So we're going to use that context there to determine this is an addition situation. So 5 degrees is being added to the original temperature. And then finally, we're going to write an expression that represents 5 degrees being added to our original temperature. And that's going to be T plus 5. So the original temperature was T and 5 degrees was added to it. So our algebraic expression is T plus 5. This expression represents the current temperature. Notice there isn't an equal sign. A lot of 7th graders are tempted to put T plus 5 equals new temperature or something like that. We don't need to do that here. This is just an expression. T plus 5 is the current temperature. We don't have to have an equal sign there to represent that. So now we're going to look at a bunch of examples and kind of interpret these and translate these word phrases into math phrases. So we want to write an algebraic expression for each situation. Half of the price. Okay, well, what's unknown in this situation? I can't actually solve this problem because I don't know what. Well, I don't know what the price is. So I need to know what the price is to do this problem, but I don't. So I'm going to use a variable to represent what the price is. And I'm going to get creative, and I'm going to use P for the price. And then what's happening to the price? We are finding half of it. Well, how do you find half of something? There's actually two ways to find half of something. So there's a couple of algebraic expressions we could write for this situation. Can you figure out what they are? Well, find half of something, you could divide it by 2. So I'm going to take the price and divide it by 2. That represents half the price. Or I could multiply it by 1/2 times P. Either one of those is half of the price. So here are two algebraic expressions that represent half of the price. Next one, I have 4 times as many baseball cards as Fred. Well, there's no way to figure out how many baseball cards I have unless I know what. What's unknown here? The unknown is how many baseball cards Fred has. So I'm going to let B represent the number of baseball cards that Fred has. So if B is the number of cards that Fred has, how many cards do I have? Well, I have 4 times that amount. Well, what does that imply? What operation? Multiplication. So I need to take Fred's cards, B, and multiply it by 4. So I can take B times 4, or I could write that as B times 4, or I could even write that as 4B. Lots of ways to write multiplication. This is probably the preferred one right here. This is a little more algebraic. I would try to avoid this one, and you could probably guess why. It's because of that little symbol right there. It kind of looks like an X, doesn't it? So when we're writing algebraic expressions, we want to avoid the multiplication symbol that's an X because it looks like an X and we're using variables. So we wouldn't want to get confused. So I would probably prefer that one right there for that situation. The quotient of a number and 7. This one's always a tricky one because of that word quotient. A lot of people forget what quotient means. Quotient means division. So we're finding the result of division of two numbers. Well, what two things are we dividing? Usually when you hear a phrase like this, the quotient of, or the sum of, the difference of, the product of, it's going to be followed by two things. And the two things that follow are a number and 7. So we're dividing a number and 7. Now, we don't know what that number is, and a lot of students are tempted to just make up a number and then just write some random number and divide it by 7, but that's not what this is saying. The number is unknown, so we have to use a variable to represent that unknown number, and we're going to use, creatively, n. A number and 7. We're finding the quotient of a number and 7, so we're dividing a number and 7. It's n divided by 7. Now, when it's written in that direction, it is not 7 divided by n because division is not commutative. I cannot write those both ways. That one would be wrong. This one is the correct representation here, n divided by 7, because when you see the phrase like this, the quotient of, this is the order that they're divided. A number divided by 7. 4 more than 3 times a number? Well, this one's getting a little more complex. Well, the first step is to identify what is unknown. 4 more than 3 times what? A number. I don't know. This is the unknown right here, some number, and I'm going to call it n. And what's happening to n? Well, I need to look at the context and look at what's happening here. 4 more than 3 times a number. Well, it looks like this number is being multiplied by 3, and then I need 4 more than that. So I'm going to write an expression here that shows 3 times this number, and I'm going to write 3n, 3 times n, and then I need 4 more than that. So I'm going to add 4. That would give me 4 more than 3 times the number. Or I could have had 4 plus 3 times n. Since addition is commutative, I could write that expression both of those ways. 8 more shirts than we have. Well, what's unknown here? Well, the number of shirts we have is unknown. I don't know how many shirts we have. So I'm going to use a letter to represent the number of shirts we have, and I'm going to use S. So S represents the number of shirts we have, and I need 8 more than that. Well, how do I get 8 more than S? I add 8 to it. So the context clues there was implying addition. So I'm going to add 8 to S. And again, I could have had 8 plus S, since addition is commutative. Either one of those algebraic expressions is doable because they are equivalent. Earning $12 per hour for H hours. Here's a situation where the unknown is given to us. Whenever you see it expressed that way, H is the unknown. So earning $12 per hour for blank hours. I don't know how many hours I was working. So how would I figure out how much I earned total for any number of hours? I would have to multiply 12 times H. That would tell me how much I earned for any number of hours, earning $12 per hour. There's that unit rate again. That goes back to when we were writing equations of proportional relationships. $12 per hour is that constant rate of change. So 12 times H represents how much money I earned for any number of hours. Next, the product of 9 and a number. Here's another one of those phrases that students forget. The product of. Product implies that we're multiplying something, and we're multiplying two things. We're multiplying 9 and a number. Well, again, I don't know what the number is. I'm not just going to make up a number, but I'm going to use a variable to represent that number. And creatively, I'm going to use n again. And I'm going to multiply 9 and a number, so 9n would be the algebraic expression for that situation. The number of feet, or sorry, the number of inches in f feet. So I know that there's 12 inches per foot. Okay, there's that unit rate again, 12 inches per foot. So if there's 12 inches for every foot, how would I find the number of inches in f feet? That means in any number of feet, what would I do? If I give you the number of feet, what do you do to that number to find the number of inches? Well, I would have to multiply the number of feet times 12. That would tell me how many inches I have. So I'm going to use my variable here, f, to represent any number of feet, and we're going to multiply that by 12. 12f represents the number of inches in any number of feet. So there's the algebraic expression that represents the number of inches. And then 14 students hang n posters each. That means we don't know how many posters they hung each, but how many posters would there be total in this situation? Well, if we knew how many posters they hung each, every one of them hung the same number of posters. So that would be equal groups, 14 groups of n. So that's implying multiplication. So how many posters did they hang total? They hung 14 times n posters. And again, I know it's difficult for some students to just write that because they want to know exactly how many posters were hung or substitute a number in there, but we just don't know, so we have to use a letter to represent that unknown. And that's writing algebraic expressions. Really, you follow that same process as find out what you don't know, and then use the clues from the context to figure out what's happening to that unknown, what operations are happening. And then here is a nice summary of the 4 main operations. These would be good to have in your notes as clues or context clues that imply operations. And I'm not going to read all of these to you, so you can kind of pause the video and read through these and write them down. But I did write the main ones at the top there. The phrase for addition, sum, we usually forget that, difference for subtraction, product for multiplication, and then there's that quotient word for division that we always kind of forget. So make sure you include these words and follow those directions for translating verbal phrases to algebraic expressions.